So today we are doing the day 6 notes. We are going to practice finding common denominators. And then this goes with the lesson that we did earlier this week about adding and subtracting rational expressions. So next week when we start, we're going to put it all together. We're going to find the common denominators, we're going to make common denominators, and we're going to add and subtract. All right, here is our first practice problem of the day. So if I wanted to turn a 7 into a 35, what would I have to do? Multiply by 5. If you're multiplying the denominator by 5, you have to multiply the numerator by 5. That's how you keep the fractions equivalent. So what would the missing numerator be? 15. Any questions? All right, once again, we're going to find the missing numerator. All right, how would I turn 3b into 15b squared? 5b. So I'm going to multiply the denominator by 5b and the numerator by 5b. What is 5b times 5? 25b. Very good. All right. Getting a little more fun, isn't it? Oh my gosh. All right, so the way we have to do this is we have to figure out what this denominator is made up of. So what did you multiply this by to make this? Rewriting something as a multiplication problem is what we call factoring. So we have to factor x squared minus 3x minus 10 first to figure out what the missing factor is. So what would multiply to negative 10 add to negative 3? Negative 5, positive 2. Okay? When you rewrite it like this, it's a lot easier to see what's missing. What's missing over here? The x plus 2. So multiply the numerator by x plus 2. What would that give me? 3x plus 6. Very good. All right, now we're going to practice finding the LCD. So LCD is the least common denominator. All right, so I'm going to look at the prime factorization of each of the denominators. So 25x squared is made up of 5 times 5 and x times x, right? 5 squared and x squared. The prime factorization of 30, and you can do a factor tree if these aren't something that you can just remember off the top of your head, is 2 times 3 times 5. Right? We do 6 and 5, and then 6 is 2 and 3. So 2 times 3 times 5. And then we have x to the 5th, y. 40. If you did a prime factorization, it'd be 2 times 2 times 2 times 5. Okay. I'm going to put all this up there, and then I'm going to explain how we do it. Now, each piece needs to be represented in the common denominator. Okay? So I'm just going to go piece by piece. Do you see the 5x squared? That needs to be there. But that covers all the other 5's too. Okay? Do you see x's? Okay, which exponent is the largest? X to the 5th. And that covers all the x's. All right, I need some 2's. How many 2's?
2 to the 3rd.
Yes, you always have to go with the largest number of that factor. 2 to the 3rd covers all the 2's. There's only one 3, there's only one y, so 3 and y. Yes, sir?
But there's no 2 or y in all of the expressions.
This isn't what you're thinking of greatest common factor, what they all have in common. This is not that. This is what could I multiply each of these denominators into. I could turn all of these into 600 x to the 5th y by multiplying them by something else. So, the easiest way to do it, the way that works every single time, is to see what each number is made up of. You do the prime factorization of each number, and then make sure that each of those factors is in your LCD. And you have to go with the largest exponent of each. All right, we'll keep practicing this. This is what we're practicing pretty much all day, so don't freak out yet. Any questions, though, as you're looking at this? Like, where'd she get the x to the 5th? Yes?
So you take the, like, the large? I'm so confused on why you take this. So you take the largest thing out of the...
Yeah, so, for example, the 5's, right?
Yeah.
This one has 5 times 5. This one only has a 5. Well, when I go to get common denominators, I can always multiply by another 5, and now they have the same amount of 5's. So you can't take factors away when you're finding a least common denominator, so you just have to add more and more and more of them.
So you take the greatest...
The largest exponent of each base,
So
yes.
even if the other ones don't have a y, but since that's...
Yeah, because I can very easily like multiply this y over y, multiply this y over y, and now they all have a y.
Okay.
Yes, so you have to go with the largest one so that it's easier to multiply them in than to take them out. All right, let's look at this one. Now, we're looking for common denominators, so we're not really worried about the numerators right now. I am going to start by seeing what each denominator is currently made out of. That's what we did on the last one with the prime factorization, but now we have to actually factor. We're rewriting it as multiplication, same basic idea, just has x's and plus and minus signs in it. So what can I factor out of 3x minus 18? Yes?
You can factor out of 3.
You can factor out a 3. So I'm going to rewrite that as 3 times x minus 6. All right, and x squared minus 36. How does that factor? That's a difference of 2 squares. So I have an x plus 6 and an x minus 6. So my LCD. What do I need in my LCD?
X plus 6.
I need an x plus 6 for sure. What else do I need? I need an x minus 6 for sure. What else do I need? A 3. So each piece has to be there. The 3 is there. That would cover any other 3's. The x minus 6 is there. That covers this x minus 6 as well. I need the x plus 6. Remember, eventually we'll get to the point where we're turning the denominators into the same thing. So like this guy you would just multiply it by x plus 6 and you'd have the common denominator. This one you'd multiply by the 3 and you'd have the common denominator. So you're trying to figure out what you can multiply each of the expressions by something else and end up with your common denominator. All this one needs is the x plus 6 and they match. All this one needs is the 3 and they match. Each piece of the factored denominator needs to be present in the common denominator. Questions? Now we're going to take it a step further. We're going to actually practice rewriting these fractions. So first we have to figure out what the LCD would be. So we need a 2, we need an x, and we need an x plus 2. Good.
Wait, so do the numerators count at all?
In this one they will. But when you're finding the LCD, we don't care what the numerators are. Yes?
So if it's like a factoring expression, kind of, or
If you can factor it, you need to factor it first so you can see what it's made of.
Oh.
None of these would factor.
I mean, if it's a term like that and you take the whole term,
Mm-hmm.
okay. So since there's like only one thing in here and then it's not.
So yeah, we have 2 monomials. So the x needs to be there, the 2 needs to be there. Yep. All right. Now, this one says actually to rewrite the fraction. So we're going to do that. The first fraction, 3 over x plus 2. What is that missing if we want to make it look just like the LCD? The 2x. If you're going to multiply the bottom by 2x, you got to multiply the top by 2x. Okay? What is 2x times 3? 6x. Now, if you want to distribute this out, you can. On these types of problems, I usually don't distribute it out till the very end because you can kind of end up going in circles. But we will for today. Just for practice. So 2x times x is 2x squared. 2x times 2 is 4x. All right. What does our middle fraction still need?
2 and x plus 2.
It needs 2 and x plus 2. So I have to multiply the top by 2 and x plus 2. Now, once you double distribute on the bottom, or single distribute in this case, that's what all the denominators will be. So this, if you multiply it out, 2x and then times x, 2x squared, 2x times the 2 is 4x. It should be the same each time. So I'm not really going to spend a lot of time multiplying that one out. What is 4 times 2? 8. What is 8 times x?
8x.
And what is 8 times 2? 16. Does everyone know where that came from? All right, and last one. What is this guy missing? The x and the x plus 2. Notice how I'm keeping it all in parentheses. If you don't keep it all in parentheses, you might end up only multiplying the x's and forgetting about the plus 2 on the end. So when in doubt, just use lots of parentheses. All right, so I have to multiply the numerator by that same thing, x times x plus 2. What's 5 times x? 5x. Now I'm going to distribute the 5x. What's 5x times x? 5x to the second. What's 5x times 2? 10x. Now, when you I keep saying double distribute, you're really just single distributing the 2x. You should end up with the same thing. If you want to go for it, do it. Now, when we come back together on Monday, it'll be the same type of problem, except we'll take it one step further. We'll like add and subtract them, okay? But this is the hardest part, just finding the common denominators. Questions? All right, so we can factor the second denominator, right?
Mm-hmm.
What can you bring out of each one?
3.
All right, so if I pull out a 3, I have x.
I pulled out a negative.
Yes. So, hold on a second.
-3, you get a positive 4.
Yeah, so I'm going to just show you this all at once. So, do you see how... I'll actually do it the way you said. I'm going to back up. We're going to go old school again. So, yes, do you see how these almost match? Okay? And if you pull out a regular 3, you'll be off by what? By a sign, right? So you could pull out a -3. That would leave me with -2 plus x. All right, so check this out. Now, trying to think of how I want to do this. Does anyone see something that's kind of like bothering them? Yes.
Wouldn't the negatives cancel out?
Yeah, you can go even further.
But no.
Switch the x and
The -3s. Do you see that?
Oh.
And now look, they already have common denominators.
So would that be the answer?
Yeah, so this could be the answer.
So the answer is another problem, basically.
No, that's the answer.
So would you just write that twice? Or could you just write it 1x minus 2?
I would write it twice since you started with 2 expressions. Now, the other way, if you didn't recognize the -3s and how they simplified out, that would be fine. Your LCD would just be -3 times x minus 2, and you'd end up multiplying this whole thing by -3, and you'd still end up with 2 fractions that were identical. Okay? Kind of tricky. So, first thing we want to do is what?
This is rewrite
Let's factor it.
this one.
Mm-hmm.
This one says to rewrite each fraction of the LCD.
Okay.
Oh, never mind.
It's the same. All right, so let's factor. What multiplies to 6 adds to 5? So x plus 3, x plus 2. All right. Back here, what multiplies to 4 adds to 4. 2 and 2. Good. So, to get my LCD, what do I need? I need an x plus 3. What else?
X plus 2.
I need an x plus 2. What else?
Another.
I need another x plus 2. There's no way you can get rid of one of these x plus 2's. Therefore, you're going to need 2 of them over here so that they are the same. You can't take away factors unless it matches with something in the numerator. Sometimes you get lucky, like on the last one we had -3 over -3. We could take that away and not worry about it with the other fractions. Here, though, we can't. There's no way to get rid of one of these, so we're going to have to end up finding a way to make this guy match. Okay? So, what are we missing in our first expression on the denominator?
An x plus 2.
An x plus 2. So I need to multiply the top by x plus 2. This time I'm actually not going to write it out. I think that the double distributing is going to make us kind of lose focus of what we're working on. So just keep it like that. Okay? Now, I'm going to distribute up here, though. What is 5 times x?
5x.
What is 5 times 2? So plus 10. Okay, that's our first fraction. All right, what's my second denominator missing? An x plus 3. So I have to multiply the top by x plus 3. Denominator, same thing. We have an x plus 3. We have an x plus 2. We have an x plus 2. Double check what you said the LCD is should be what each denominator is. If it's not, you didn't multiply that rational expression, that fraction, by the right thing, okay? Now, what is negative 3 times x? What is negative 3 times positive 3? All right. There you go. Questions? That is your answer.
If we were writing it and we wanted to save time, could we just write x plus 2 squared?
So I currently have 3 denominators, none of which can be factored. So let's start picking out the pieces of what I'm going to need in my LCD. What am I going to need? I'm going to need an A. I'm going to need a B. I'm going to need an A plus B. There is no way to just add, let's say, an A right here. There's no way to like put a plus sign and a B right here. So you actually need to multiply by that whole binomial, okay? So we have monomial, monomial, binomial. All 3 of those need to be in the LCD. What is the first one missing? A and B. So this is going to be 9AB over, I'm going to write the A and the B in the front. It would be A squared B plus AB squared. But I'm going to leave it like that. All right. The middle one, what are we missing? We're missing the B and the A plus B. So I need to multiply the 4 by B and A plus B. Denominator's the same. That's why we call it the common denominator. I am going to distribute out on the top, though. What is 4 times B?
4B.
What's 4B times A? 4AB. What is 4B times B?
4A squared.
4 what?
4B squared.
B squared. Good. All right. And finally, what is the third rational expression missing?
A plus B.
A times A plus B over A times A plus B. Denominator, A, B times A plus B. What's 3 times A?
3A.
3A times A? 3A squared plus 3AB. Good. Questions? These are kind of tricky. Yeah.
If you don't distribute it back out, are you gonna get it wrong?
So on Monday, the reason I'm having us distribute in the numerator and not the denominator is on Monday, the only thing we need to know about the denominator is that it's the same. And you can tell that they're the same without distributing, right? On the numerators, that's where we're actually going to do the adding and subtracting on Monday, so we need to know what terms are alike. So that's why we're distributing in the numerators, to get the like terms to where we could add and subtract all of them. The denominators, we can keep it written as multiplication. So that's the difference. So if you don't distribute today, it's not a huge deal, but if you don't distribute on Monday, you won't be able to do it. So that's kind of why we're practicing the distributing in the numerators, but not so concerned with the denominators. All right, final example of the week. That feels nice. All right, let's rewrite these factored. So I have 3x over, how would I write that factored? Take a 2 out, which would leave us with x minus 2. How can I factor the second expression? It's a difference of 2 squared. So I have an x minus 2 and an x plus 2. All right, what do I need in my LCD?
X plus 2.
I need an x plus 2.
X minus 2.
I need an x minus 2.
And a 2.
And a 2.
Another x minus 2.
I thought that was only whenever we have 3.
Does one of the expressions have 2 x minus 2's?
No.
Then you don't need 2 of them. Right now they each have 1, and all that's going to mean is that we don't have to multiply either one of them by that. They already have it. So yeah, don't add another one, then we're going to have to really start multiplying it out. Nope, we're good right now. All right. What is my first expression missing? X plus 2 over x plus 2. Good. What's 3 times x?
3x.
To the second. What is 3x times 2?
6x.
Good. And then all over that common denominator. Again, I'm not super concerned with you distributing these out. It's actually easier if you don't distribute them out. And again, you'll see why on Monday. Sometimes after you add and subtract, some things will simplify. So if you distribute it out, you'll end up factoring it. Then the next step, you're just going in circles. Anyway, we'll cover that another day. The x minus 2, x plus 2 is missing what?
2.
The 2. So I'm going to multiply by 2 over 2. All right, what is 1 times 2?
2.
2. And then the denominator is just that same old thing. All right, what are your questions? Yes?
You can take off where you simplify the bottom denominator.
No. All right, any questions? Yeah, LCDs is a real easy way to state that, and that stands for least common denominator. I've said this like 4 times already today. The whole point of this is that next week we're going to have adding and subtracting problems that don't already have common denominators. Tuesday we did the lesson, Tuesday of this week, day 4, was all about when they already had common denominators. Now we know how to make common denominators. Monday we're going to put it all together. Any questions?